In our earlier project, we used the built-in h-speed and v-speed. We're going to make our own custom versions of those. So I'm going to call what we used to call h-speed, we're going to call it hsp, and we're going to initialize it to 0. For vertical speed, our own custom version, we'll call it vsp. We're going to have a gravity one, which we used in the koala game, but we're not going to use the built-in one. So we're going to call it grv, and we're going to set that to 0.34. And we're going to have a variable that will set how quickly the player is going to walk. So we'll set that to we'll call it walk sp, and we will set it to 4. We're going to allow our player eventually to be able to run. So we're going to set a run speed equal to 8. And we're going to have player have health eventually. So we'll say player health, and we'll set that equal to 100. And so those are our movement variables. Let's just stick with those for now. Actually, I guess health isn't really a movement variable. Put it down here. Player variables. Okay. All right, but for now we're going to primarily be focusing on these movement variables to get us going so the player can start moving around. So let's we've got these things set up and initialized. Let's go in now to our step event, and we'll use the step event to detect input from the player. And for this, we'll use a modified version of what we did in the koala game, and in fact it's a modified version of a script for movement in koala that I put up on the Blackboard site. So we'll say detect movement, and then maybe other stuff we're going to do later, and we'll say and shooting. So eventually we're going to do shooting too. Okay. So what are we going to do to detect movement? Well, we need to get the player's input first. So we'll put in a comment here, get player input. What we're going to do is we have been working with detecting which key the player presses and then taking that information to move them one direction or another. So we're going to use a very neat approach to doing this here that it takes a bit of information from the way Sean Spalding does this and a bit of information from the way that the Heartbeast guy does it, and then we'll use bits and pieces of both. So we're going to set an instance variable that we're going to call keyboard or key left, and we're going to set our own custom instance variable called key left equal to keyboard check, and then for the left we want to use the A key. So to check for a specific key we can use this built-in function called ord, and we're going to pass it which key we want to check for. All right, so if the keyboard, we're going to set keyboard left equal to keyboard check ord A. Oh, so what does that mean? What that means is if the player presses the A key, then this key left variable will contain the number 1, which means true. So it's going to check, are they pressing the A key? If that's true, then key left will be equal to 1. And if they're not pressing the A key, then key left will be equal to 0. All right. Before we move on, I'd also want to give a bit of flexibility to our player. So in a typical platformer game or a shooter game, in addition to using the A, S, D, and W keys for movement, you typically want to let the player also use the arrow keys. So while we're here, let's do this. We will say key left equals, and then we'll check, are they pressing the A key? Or, and we use these two sort of bar symbols, you remember from our discussion of if statements, if we want to check if one thing is true or the other thing is true, we'll say keyboard check. And the thing we're going to check for now is the virtual key left. And this is what we've used prior to now, right? We use this virtual key check for space and return and shift and so on. Right? So how does this work? Well, it works in a similar way. If the player is pressing the A key, or if the player is pressing the left key, and if either of these things is true, then key left will be equal to 1. And if neither of these things is true, then key left will be equal to 0. Right? And well, you're going to use this as 0 and 1 in a very specific way in just a moment. Okay. Let's save ourselves a little energy here by copying and pasting that in. And let's change now and check for the right key, if I can spell the word right. And what are we using for the key? We're going to use the D key. Oops, I can type correctly. There we go. Or the right arrow. Okay. So same idea. Right? It's either going to be equal to 0 or 1. As long as we're here, let's just stick with this for the moment. All right, so we've got a left key and a right key, and we're going to add in a jump key and also a run key. But let's start basic with our left and right. Next thing I want to do is I want to make use of the values that are in this left and right key. And I'm going to create a local variable by using the keyword var, and I'm going to call the local variable move, and I'm going to set it equal to key right minus key left. So think a minute, what are the possible values for this local move variable? Well, if both of these is equal to 1, then key move will be 0. That means if the player is pressing the left and the right keys simultaneously, we don't want them to move. And what that means in this case is it will have 1 minus 1, that will be equal to 0. And we're going to use 0 to mean don't move. If the left key is pressed and the right key isn't, what does that mean? Well, this will be 0, this will be 1, so move will be minus 1. And we're going to use minus 1 to indicate that we want to move left. Similarly, if the right key is pressed and the left key isn't pressed, then this will be 1 minus 0, and move will be equal to 1, which we're going to use to indicate that we want to move to the right. Okay? Let's move forward. So what are we going to do with that move value? Well, what we're going to do is we are going to set their horizontal speed. Remember, we set our own custom instance variable for horizontal speed that we called HSP. And we're going to set HSP equal to the value in move, which is either going to be 1, 0, or -1, times our walk speed, which we set at the beginning, right? In our create, we set horizontal speed to 0, our own custom version, and we set our walk speed equal to 4. So what that means is that we're going to set our own custom version of horizontal speed to either be 4 or 0 or -4. So that will ultimately cause our player to move 4 pixels per step to the left, 4 pixels per step to the right, or not moving at all. All right, good. So that works pretty well. Let's see what we need to do next to make all of that crazy stuff work. Well, there's really only one more thing we need to do. We're using our own custom version of horizontal speed here, right? So even though we change the value of this on each step, we're not actually moving our player, right? Because it doesn't know what this thing is. So to actually move our player, we'll take the x coordinate of the player at this moment, and we're going to add to the current position, the x coordinate, whatever the value is of HSP. So if the value is 4, it means we're going to move 4 pixels to the right. If it's -4, we're going to move 4 pixels to the left. And if it's 0, we're just going to stay right where we're at. So let's go back into our room. And we will, I can get it to open, there we go. And in our room here, we have a background layer, tiles, walls, and instances. I'd like to rename this instances layer, and I'm going to call it player. I'll select that player and come over to our player object and drag it out and plop it down on the ground here. Okay. And hit play. Now there's a whole bunch of stuff that's not going to work yet, but there is some stuff that will work. You can see, because we have an animated image for our player, which is essentially an idle image, it's automatically playing its animation. And on my keyboard now, I'm pressing the left key and the right key, and when I let go, it stops moving. If I hold down both, it doesn't move. If I come over to the wall, though, I just walk right through the walls, because we haven't set up anything yet to make that not do that. And of course, our player is not facing the right direction when we move left, but look at there, we do have our player moving around in the room already. All right, let's set things up so that our player can recognize when it runs into a wall, and we'll also recognize if it is coming up to a ledge and is going to drop down. So let's go back into our player and back into the step event. And this step event's going to start getting bigger and bigger in terms of the amount of code as we go along. So I want to introduce to you the idea of how you can organize conceptually related hunks of code that you have got inside a single script here in GameMaker. So what I want to do is I'm going to come in right up near the top before our get player input, and I'm going to put in a hashtag, and I'm going to write in the word region. And this is going to be the region of code that takes care of getting player input. And this is just a special, it's not a function, it's not a variable, it's just something that allows GameMaker to recognize that we are going to define a specific region of code that has a beginning and an end. And this marks the beginning of the region. And to mark the end of the region, we do another hash symbol and say end region. Now what does that mean? What does that actually do? Well, once I type in region and end region, GameMaker will automatically allow me to now collapse and expand that hunk of code. It's very handy as things start to get big. If I want to work on some other section, I can close up all the other regions of code and just focus in on the piece that I want to work with. So this will be our input region. And then the next region, we'll have another one. And we're going to have this region be one that takes care of calculating movement. All right, so we've started off with all of this stuff that we've got in here. So we'll put another one in region, like so. But I'm going to create a new region that will specifically be focused on code to detect and deal with collisions with walls. Okay, so in fact, that's what we'll call it. We'll call it collision and more movement. All right. The first thing we want to do is to detect when our player is moving across the room, left or right, and encounters one of our wall objects. And what we want to have occur in that case is for the player to not be able to move through the wall. So in our earliest games, we just used on collision. In fact, we used it quite a bit, and we'll use it later on in this game. But in our koala game, if you remember, we didn't use on collision, and instead we used place meeting to detect if the koala object were to move into a specific location, would it encounter a wall or not? So we're going to use that approach here to detect if our player is going to run into a wall. So we'll put in an if statement, and what we're going to check is if place meeting And where do we want to look? We need to say, where do we want to move our player to behind the scenes to see if it's going to run into a wall? Well, we're going to take its current X position and we're going to add to it the value that is stored in horizontal speed, which is either going to be 4, -4, or 0. So what that will allow us to do is to look 4 pixels to the left in our case, or 4 pixels to the right in our case. Okay. Then for the Y value, we're just going to check right where we're at. We're not looking up or down. And then which object do we want to see if we're going to run into? Well, we want to see if we're going to run into the wall. Okay. So if we look to our left and we look to our right, and in either of those places we're going to run into a wall, what do we want to do? Here's where things get a little tricky, something we've not tried yet. We're looking 4 pixels to the left or 4 pixels to the right, but what we want to allow our player to do is, if they were to move 4 pixels to the right and run into a wall, we don't want to stop them right where they're at, because that would stop them 4 pixels away from the wall. But we actually want to get them right up next to the wall before they stop. So to accomplish that, we're going to use a while statement, which we've not done yet. A while statement is like a repeat loop. It's something that we will keep doing over and over and over until a specific condition is met. And what condition do we want to check for in this case? Well, we'll check to our left, let's say, and see if there's a wall 4 pixels away. And if there is, we want to move pixel by pixel by pixel right up to the point that we actually touch that wall. So we can do that by saying, while not place meeting X, right? And then what? Well, we want to go 1 pixel by 1 pixel. So as long as we look 1 pixel to our left or right and there's no wall there, we're going to move 1 pixel left or right. So how do we do that in one piece of code? Check 1 pixel to the left or 1 pixel to the right. Well, we're going to make use of a clever bit of coding that both our Heartbeast friend and Sean Spalding use in their own code, which I love dearly. And that's the following. We're going to say, take our current X position of our player, then we're going to use, we'll say, plus a built-in function called sign HSP. Now, what does that mean? If the value of HSP is positive, by using the sign function, it will give us a value of 1, positive 1. If the sign is positive, it means the value will be 1. If the value of our hspeed is negative, then its sign will be negative, which returns a value of -1. So by using this sign, coupling it with the value of HSP, we return a -1 or a 1, which allows us to look 1 pixel to the left or 1 pixel to the right. Brilliant. All right, so that's where we will look on the X coordinate. Y, of course, we'll just look along the same Y, and what are we looking for again? We're looking to see if we're going to collide with the wall. So what this says is that while we are not going to run into the wall 1 pixel to the left of us or 1 pixel to the right of us, then what? Then we want to move. So to move, we'll just take our X and we will add to it, can you guess what? Sign HSP. So we will either move 1 pixel to the right if sign is positive of HSP, or 1 pixel to the left if sign is negative for HSP. Now what happens when this is no longer true? This will keep going and going and going until it reaches a point where we are going to run into the wall if we move 1 pixel to the left or 1 pixel to the right. And it will then break out of this loop. At that point then we want to stop moving. And we can stop moving by setting the HSP equal to 0. Perfect. Okay. And remember, when all that happens, at the same time, this isn't a step event, so all this stuff is happening every step. And one of the things that's happening every step is that we are updating our x coordinate. This is the actual thing that's moving us by adding the value of HSP. And in this case, we are moving up to a wall, and then we're setting HSP to 0, which means that we will stop. And in fact, if I want to be cautious, I think probably what I should do, since this is going to happen before this, just to make sure we're not causing ourselves any problems, let's take that movement code itself and we'll move it down underneath here. Okay, so that will allow us to set the value of HSP here, also set the value of HSP here, but then actually do the moving itself once we've done all those checks. And I may give myself a little reminder of what's happening. Actually move horizontally. Okay. Well, let's come back to our player sprite and go to the collision mask, open it up, and switch from manual or automatic mode into manual mode, and we're going to reposition this thing. Now, I played around with a lot of different variations on where to have the collision mask, and I found that setting it to roughly 15 by 15 and say 39 for the right and for the bottom, doing 62 seemed to work pretty well. Now look at how this is going to function. We don't have a collision mask at the top of his head, on his left or right arms. What that means is visually, when this guy is out in our room and comes up against a wall, his right and left arms actually will appear in front of those walls, which is kind of a cool visual effect. And a bit later, we're going to allow our guy to jump, and when he jumps, it'll make it so that if he jumps and hits a platform, his head will appear just in front of the platform. And you can decide whether you like that or not, but I'll leave it that way for now. And now, when I move him left and right, he stops when he encounters one of these walls. And you can see, because of the way we set up the collision mask, we get a nice visual effect of his arm appearing in front of the wall, and over here, same thing. Okay. Looks like he's on the floor, but he's sort of positioned slightly in front of these wall objects. So that's pretty neat. We can get that to work. Be nice if he were able to jump. So why don't we take a look at that next.